Welcome to the Explainer. Have you ever wondered what makes a planet spin or a baseball fly through the air? Well, it turns out the rules that govern all of that are actually simpler than you might think. Today, we're going to break down the fundamental principles that control every single moving thing in the entire universe.
Okay, so let's kick things off with something you've probably seen happen a million times. You take a dusty carpet, you whack it with a stick, and poof, a cloud of dust. But why? See, the secret isn't that you're knocking the dust out, it's that you're moving the carpet away from the dust. And that simple idea, well, it unlocks one of the most fundamental laws of the universe.
To really get a grip on motion, we first have to understand the tendency of things to do absolutely nothing. It sounds kind of funny, right? But it's a core principle of physics. Objects just prefer to keep on doing whatever it is they're already doing. All right, let's dive into what that really means.
So this is the official rule, laid out by the one and only Isaac Newton. And put simply, it just means that things at rest want to stay at rest, and things that are moving want to keep moving. Just picture an asteroid drifting through the blackness of deep space. It's going to keep moving in a perfectly straight line at the exact same speed, basically forever, because there's nothing out there to push it or pull it. Nothing changes unless something makes it change.
And this resistance, this opposition to change, it has a name: inertia. You can really think of it as a kind of cosmic stubbornness. The more massive something is, the more stuff it's made of, the more inertia it has, and the harder you have to work to change its motion.
And we see this everywhere, all the time. You know that feeling when a bus suddenly moves forward? Your body's inertia wants to stay put, so it feels like you're being thrown backward. And that brings us right back to our dusty carpet. The stick moves the carpet, but the dust's inertia makes it stay right where it was for a split second, and that's how they separate. It's happening all around us.
Okay, so let's build on this idea. If everything is kind of lazy because of inertia, what does it take to force a change? What do we actually need to make something start moving or to make it stop?
And the answer is energy. Now, in physics, work is what we call it when a force actually causes something to move. And energy, well, energy is the currency you have to spend to get that work done. If you don't have any energy, nothing changes. Inertia just wins every single time.
For objects that are moving around, this energy basically comes in two main flavors. You've got kinetic energy, which is the energy of active motion. The faster something is moving and the more mass it has, the more kinetic energy it's got. That's what the M for mass and V for velocity are all about in that formula. Then you have potential energy. That's stored energy. Think of a book you're holding up high. It has potential energy because of its mass, its height, that's the H, and the pull of gravity, G. It's just waiting to be released.
Now here's a fun little physics mindbender for you. In the language of physics, if the force you're applying isn't in the same direction that something is moving, you're not actually doing work on it. So even though it feels like really hard work to carry a heavy load, because gravity is pulling down while the person is moving forward, technically, no work is being done against gravity. Weird, right?
All right, so we've talked about inertia, which is what resists change, and we've talked about energy, which is what creates change. So now let's look at the universal force that is constantly, always influencing motion everywhere you look, from an apple falling off a tree to a galaxy spinning out in space. But let's start with something that might surprise you. Despite its massive universe-shaping impact, gravity is actually the most feeble of the four fundamental forces of nature. I mean, think about it. A tiny little refrigerator magnet can overcome the gravitational pull of the entire Earth just to hold up a piece of paper. It's incredibly weak, and yet it runs the whole show.
So what is it exactly? It's this fundamental attraction that everything with mass has for everything else with mass. It's not just the Earth pulling on you. Right now, you are pulling back on the Earth. It's true. The more mass something has, the stronger the pull. And the farther things get from each other, the weaker that pull becomes. It's this simple, elegant rule that applies to everything everywhere.
Here on our home turf, on Earth, that universal attraction gives us a constant downward pull. If you ignore air resistance, any object you drop will speed up as it falls, accelerating downwards at this very specific rate. You know, what that really means is that after just 1 second of falling, an object is already going over 20 miles an hour. After 2 seconds, it's over 40. That's what 9.8 meters per second is all about.
And this brings us to a really important distinction that gravity creates: the difference between mass and weight. Your mass is the actual amount of stuff you are made of. It's a scalar, which just means it's a number, like 70 kilograms. That number is the same everywhere. Your weight, on the other hand, is a vector. It has a number and direction, because it's the force of gravity pulling down on your mass. If you went to the moon, where gravity is much weaker, your mass would be exactly the same, but you would weigh only about 1/6 of what you do here.
You have definitely felt this before. Get in an elevator. When it suddenly accelerates upward, the floor has to push harder on you to overcome your inertia, and for a second you feel heavier. When it accelerates downward, it's not pushing up on you as hard, and you feel lighter. Your mass didn't change at all, but the force you feel, your apparent weight, totally did.
So let's tie all of this together. It's actually a pretty beautiful picture. These three concepts, they're all woven together. Inertia is universe's default setting, its tendency to just keep things the same. Energy is the fuel you have to burn to overcome that default setting and actually cause a change. And gravity is that invisible, ever-present force that's constantly trying to direct that change on a massive cosmic scale.
And so that leaves us with one last, kind of mind-bending question to chew on. If a tiny little magnet can beat it, how on earth does this incredibly weak force manage to be the master of planets and stars and entire galaxies? It's something to think about. Thanks for joining this explainer.